now that we've identified three special triangles that we're going to be using in our trig functions, let's see what those triangles are actually going to get us. How does that work for us? And if you think about the triangles, the 30, the 60, and the 45-degree triangles, they were all triangles, they were all acute triangles. So let's put that in relation to reference angles. So when we talk about a reference angle is as defined here. A reference angle is a positive acute angle theta prime that's formed by the terminal side of theta and the x-axis. So what does that mean exactly? What that says is that if I have my angle theta that has rotated in this first image over here, if I have my angle theta that has rotated and is now stopped in the second quadrant, then theta prime, which is what we call the reference angle, is formed by the terminal side of theta and the x-axis. So this little bitty pie shape within here is the reference angle that we're referring to. And all reference angles are acute angles. So when I want to identify a reference angle, I need to be looking for some angle that is between 0 and 90 degrees. Now, the three images that you see here in this graphic are all telling us what I'm going to be either adding or subtracting to based on where the terminal side of my angle stopped at. So if theta rotates and stops over here in the second quadrant, then I'm going to be subtracting to figure out what theta prime is. I'm going to be subtracting from 180 to figure out what theta prime is. Because if I were to rotate all the way to 180 but then back up, I end up with my reference angle right here. So second quadrant says I'm going to subtract from 180. But if I've rotated theta in this second image over here, if I rotate theta and I end up in the third quadrant, what am I going to do to find the reference angle? This time I'm going to have to subtract that reference angle from 180, right? So this value right here is going to be, I'm not from 180, I am going to subtract 180 from that value to get that reference angle, or I might even add 180 to end up at that angle as well. And then on the third image over here, if I rotate theta all the way around to the fourth quadrant, I would be subtracting from 360 to figure out what this sliver of a pie shape value is over here. Notice that every time we were talking about a reference angle, we were either adding or subtracting off of only the x-axis. And that is very, very important. We're going to adding or subtracting, whichever way you look at it, from the x-axis only. It does not work out for you if you add or subtract off of the y-axis. That's not always going to be consistent. So all reference angles are acute angles, values that are between 0 and 90, and they are either added or subtracted off of the horizontal axis or the x-axis. So let's come down here and let's look at three examples together. The first example that we want to look at says I want to figure out what the reference angle is for 218 degrees. So it usually helps if I'm drawing an image here. If I have 218 degrees and I rotate theta, then I've stopped over here in the third quadrant. So that's going to be theta. So what I'm interested in finding is, what is this little bitty reference angle right here, the angle formed from the x-axis and my terminal side. So to find that value, I'm going to take 218, subtract 180 degrees, and I find out that that little value is 38 degrees. So let's look at the next example then. It's a little bit more complicated. I have 1387. So 1387, I have no idea how many times around the circle that's going to be, so let's use our calculator to figure that out. If I were to say 1387 divided by 1 revolution, which is 360 degrees, I'm going to get approximately 3.8. So my circle says I'm going to go around 3 times plus more. So if I'm rotating here, I'm going to go around 1, 2, 3 times, and almost make it to 4, but I'm not quite there. So how far did I make it? Well, let's take the 1387 and let's subtract 3 revolutions, so 3 times 360. When we do that, we find out that that's 307 degrees. Now, to bring this back to what we may have learned earlier, 307 degrees, so if I rotate 307 degrees and stop in the 4th quadrant, or if I rotate 1,387 degrees, I still land in the exact same spot in the 4th quadrant. And remember, those two angles are called coterminal. Those are coterminal angles to each other. But what I'm interested in finding is, I want to know what the reference angle is. What is this little pie shape that is the remaining value between the 4th quadrant and all the way around to the 360? So we find that by taking 360 minus the 307 degrees, which was from the 4th quadrant, and we'll see that that value is 53 degrees. So 1387 and 307 are coterminal to each other, but 53 is the reference angle for these. Kind of confusing when you start thinking of reference and coterminal. Now the last one we're going to look at is even a little bit more difficult, or I would say challenging. Let's start by drawing negative 135. So if I were to sketch the graph of negative 135, remember if I rotate negatively, then I start on the x-axis and I rotate clockwise. So if I rotate negative 135, I'm over here in the 3rd quadrant again. So this is negative 135. Ultimately, I'm only interested in that small little pie shape over there, but I could approach this if I wanted to think about coterminal again. So let's find a coterminal angle, or a positive angle that's coterminal to negative 135. So in other words, if I were to rotate positively and end in that exact same location, how much will I have rotated? Well, we find that by taking 360, subtracting the negative 135, or subtracting 135, and what we find is we end up with 225. So the positive rotation is 225 degrees, the negative rotation is negative 135 degrees, but ultimately they're in the same spot. So what is then the reference angle, this little bitty acute angle here that is formed between the horizontal axis and the terminal side of my angle? So we come back here then, and we're going to take my 225 degrees that I rotated positively, subtract off 180, and we end up with 45 degrees. So that little bitty acute angle ends up being 45 degrees.